Okay, in this video we're going to take a look at a technique called method of differences, and it's a similar style of question to what we were looking at earlier with these series style questions, but you've got to realise that like the ones that we were looking at before would only add up the square numbers or the cube numbers or the natural numbers, and like there's lots of different types of sequences that won't necessarily be square numbers or cube numbers. And this technique, method of differences, is a really useful one if the sequence that we're adding up is of this sort of form. So it's like f of r plus 1 minus f of r, or f of r minus f of r plus 1. So if you look at what we're being asked to add up, we've got 1 over r minus 1 over r plus 1. So we could identify that as, well, that's a function of r minus a function of r plus 1. It's like, if the function was 1 over x, then f of r would be 1 over r, and then f of r plus 1 would be 1 over r plus 1. But to be perfectly honest, in the exam, it'll tell you to use method of differences. You can pretty much guarantee it will. So you know that we're going to be using this technique, but just in case it doesn't, the reason why we're using method of differences is we're looking for like a function minus a function, and if that happens, we can use this technique. Okay, so the way that we do it is we actually need to give ourselves quite a bit of space. So you want to, you want to make sure if you get a question like this, you've got like a good few lines to do your working out. Okay, so I'm going to start over here to give myself enough space. And if we sub 1 in, the terms themselves, think about what they would look like. So it would be 1 over 1 minus 1 over 2. If we sub 2 in, it would be 1 over 2 minus 1 over 3. If we sub 3 in, it would be 1 over 3 minus 1 over 4. Now don't forget what we're doing, like we're adding up each of these terms. So like that would be our first term, but can you see that if we added all of these together, we've got 1 and we've got minus half, then we're adding a half and minus a third. We've got minus half and we've got a half, and that term would cancel. Right? They would cancel each other out. Just like here, we've got minus a third in this term, but we've got plus a third in this term. That would also cancel each other out. And this cancelling pattern would just keep repeating. Okay, so what we could then say is, well, dot, dot, dot. Let's sub in. So we're ending with n. There's n terms altogether. So if we say, well, what would the nth term look like? It would be 1 over n minus 1 over n plus 1. And you can carry this cancelling pattern down, and we can see that, well, everything would cancel and we'd be left with this. But just to sort of justify this, let's go backwards a bit and see what the second to last term would be. So if we sub n minus 1 in, it would be 1 over n minus 1 minus, if you sub n minus 1 into this, it would be n minus 1 plus 1. So it would be 1 over n. And look, that's got 1 over n and that's got minus 1 over n. So you can see that's going to cancel as well. If we do n minus 2, just to check, that would be 1 over n minus 2 minus 1 over n minus 2 into this would be n minus 1. And that's going to cancel as well. So all of these terms would have just cancelled each other out. So when we add them all up, we're just going to be left with this term plus this term. So we could say, therefore, that would equal 1 over 1 plus minus 1 over n plus 1, because everything else will cancel. And we're aiming to get this answer. Okay, so all we've got to then do is group it into a single fraction. And if you want a single fraction, you need a common denominator, don't you? So if you think about 1, we could write that as n plus 1 divided by n plus 1 minus 1 over n plus 1. And when we've got a common denominator, we can then subtract. So n plus 1 minus 1 would leave with n over n plus 1 as required. And like this is the method, like we'll do a couple more, but essentially method of differences, set it out like this, see what cancels out, and then everything that you're left with is going to give you your answer for adding them up. Because of this pattern of if it's like the next term minus the previous term, or one term minus the next term, they always cancel. The pattern with the cancelling might be a little bit different, and we'll see that in the next couple of questions, but you're looking for what cancels, and then everything else is what you're left with. Okay. Okay, example 2. First part of the question is like a show question, and essentially all it wants us to do is show that if we've got these two fractions, it's going to be equivalent to this single fraction. And the reason why it's doing this is because next in the question, we're asked to add up this sequence that looks like this. But while we've got this single fraction, like we couldn't use a method of differences. Like this is not a function minus a function. This is just one single fraction. So what we need to realise is that clearly this form here is going to be useful because now we've got a function minus a function. Okay, so this one is like f of r minus f of r plus 1, because like, and I know it's r plus 1 and r plus 2, but if you think about it, if r was r plus 1, then r plus 1 would be r plus 2. So again, we're comparing it with this function minus function. Okay, all we need to realise is that if we've got something minus something, we can start subbing in and see what cancels. Alright, but before we do that, let's just show that this is equivalent to this. Okay, so for part A, if we want to subtract these two fractions, we need a common denominator. Now, because we've got r plus 1 and we've got r plus 2, we're going to need to write them both over r plus 1, r plus 2. So we're multiplying this one by r plus 2, multiplying this one by r plus 1. And then when we've got a common denominator, we can subtract. Just be careful with the negative because you subtract them both of these terms. Okay, so that would give us r plus 2 minus r minus 1, which would be 1 over r plus 1, r plus 2. Okay, now for part B. Again, give yourself enough space. We're gonna be thinking about this. This is what our terms look like. So if r equals 1, we've got 1 over 2 minus 1 over 3. If r equals 2, we've got 1 over 3 minus 1 over 4. If r equals 3, got 1 over 4 minus 1 over 5. If r equals n, we've got 1 over n plus 1 minus 1 over n plus 2. If r equals n minus 1, if we sub n minus 1 in, n minus 1 plus 1, so it'll be 1 over n. N minus 1 plus 2, so it'll be 1 over n plus 1, and see that that cancelling is still going to happen there, isn't it? As a rule of thumb, like I would always show like 3 terms, because then you can clearly see this cancelling pattern. So, I mean, you're probably confident after you've done 2, but it's just good practice to show 3 sets, because then you can clearly see that everything cancels, and then what you're going to be left with. If we sub n minus 2 in, that would be 1 over n minus 2 plus 1, so n minus 1. N minus 2 plus 2, so that'd be minus 1 over n. So now we can start to see that all the terms are going to cancel, and if this were to carry on, that would have cancelled with that one, even though we didn't write it down. That one cancels with that one, and we're just left with these two terms. So we've got a half plus, because remember we were adding all these terms together, and then it'll be minus 1 over n plus 2. So we're trying to get it into this form, and it says k is an element of z. Don't forget z stands for the integers, so it could be positive, it could be negative, but we're looking for like an integer value for k. Alright, let's just give myself a bit more space. So common denominator, we've got a half minus 1 over n plus 2. So I'm going to need 2 and n plus 2. So I'll times this one by n plus 2. And I'll times this one by 2. Then when we subtract, n plus 2 minus 2 would leave me with just n, wouldn't it? So that's the form that we want, and therefore k is equal to 2, isn't it? Okay, let's try one more. Okay, last one. For the video, we've got a slightly more complicated set of fractions, but again, it's still a function minus a function. And if you compare this, r plus 1, and then r plus 1, r plus 2, so it's sometimes you will see some in the examples where it's this way around, but this one again is a function minus the function, so the cancelling pattern is going to be this way. If it was ever the other way around, the cancelling pattern will be the other way, and we will see some of those as well. But let's first of all show this is equivalent to these two separate things, and then the last part of the question, we're actually evaluating the first 20 terms. Okay, so we're going to have to first show this, then get a formula that we can use to find the first 20 terms. Okay, so 2r plus 1 over r plus 1 minus 2r plus 3 over r plus 1, r plus 2. We need a common denominator. Now they've both got r plus 1 already, but this one needs an r plus 2 and this one needs an r. Okay. To save myself a bit of time, I'm going to group them as well at the same point. So we've got a common denominator, multiply this one by r plus 2, multiply this one by r. Now we can tidy up what's on top, so that's going to give us 2r squared plus 4r plus 5r plus 2 minus 2r squared minus 3r. So we can cancel. And then we've got 5r minus 3r, which is 2r plus 2 divided by r plus 1, r plus 2. And you might think, well, that's not the same as what we wanted, but notice that there's not an r plus 1. And also notice here that we can take a factor of 2 out, so that would be equivalent to 2 lots of r plus 1. And now we can cancel them and be left with 2 over r times r plus 2. Okay, so now we need to evaluate the sum of the first 20 terms. And let's see how we're going to do that using the method of differences. Okay, so this sum that we're being asked about is the same as these two separate things being subtracted, because we know that they're equivalent. So if we sub 1 in, we're going to get 3 over 1 times 2 minus sub 1 in, so that'll be 5 over 2 times 3. If we sub 2 in, we're going to get 5 over 2 times 3, which is 5 over 6, and straight away we can see that they're going to cancel. That's where our cancelling happens. But let's do a bit more just to justify to the examiner. Okay, so if we sub 2 into this one, so that'd be 7 over 3 times 4, which would be 12. Sub 3 in, that'd be 7 over 12. Sub 3 into this one, so that'd be 9 over 4 times 5. Okay, if we sub n in, that'd be 2n plus 1 over n plus 1 minus 2n plus 3 over n plus 1n plus 2. If we sub n minus 1 in, you might want to use a bracket for this. Well, you do need to, but just be careful. Okay, when we sub n minus 1 in, 2 lots of n minus 1 would be 2n minus 2, and then we're going to add 1, so that would be 2n minus 1 divided by n minus 1 times by n minus 2 lots of n minus 1 would be 2n minus 3 plus 3, so that would be 2n divided by n minus 1 plus 2, so n plus 1. Okay, what have I done wrong there? Oh, sorry. We're doing 2 lots of n minus 1, so it would be 2n minus 2 plus 3, so it would be 2n plus 1. Notice I knew something had gone wrong, because they're clearly going to cancel, aren't they? So I knew they were going to be equivalent, because this is our cancelling pattern. I mean, you can probably get away with that there, especially because this is getting a bit messy algebraically, but if you did want to do n minus 2, that would cancel with that one there. Okay, I suppose we could just very quickly just pretend we've done that. We know that's going to be 2n minus 1 over n minus 1n. You can see that they're cancelling. Okay, so we're being asked for the sum of the first 20 terms. We know that we can do the shortcut for this, they'll all cancel, and we're left with that one and that one. So the sum would equal 3 over 2 plus minus 2n plus 3 divided by m plus 1 n minus n plus 2. And usually at this point you want to group these together into a single expression, but because we're just being asked for the sum of the first 20, we could therefore just sub in 20 into this, because remember how this works. This expression that we end up with is like a quick way of evaluating these sums. So if we wanted the sum of the first n, we'd have to leave it in terms of n, but because we want the sum of the first 20, we say, well, therefore n equals 20, and this will evaluate that summation of all those terms for us. So it would be 3 over 2 minus 40 plus 3 divided by 21 times 22, and that should give us 325. Okay, let's see what we get then. So that should give us 3 over 2 minus 40 plus 3, which would be 43, divided by 21 times 22, and that gives us 325 over 231. which is what we wanted. Alright guys, thank you.